Okay, so we're making a pizza map tonight. And the way we're going to do that is we're going to start by talking about the data, the source data. There is no definitive list of pizza places available for you to download. That type of information is not something that's readily available. You can use a tool like Google to try to find that sort of information, and Google Maps is pretty good, but it's not necessarily comprehensive. And what we want to do tonight is be as comprehensive as we can. And there was the inspiration for this map was the Detroitography Group's Pizza Map of Detroit. And they used a very clever way to get at that data. I want to give all credit where it's due to those folks. And what they did is they used health department restaurant inspection data to identify pizza places. And I just want to stop there before we go any further and talk about like that kind of approach, where the data that you want is not available, or it's not available to you, it's not available in a readily digestible form. You have to look for alternative ways to get it, proxy measures, maybe ways to look for information that might indicate what you're looking for rather than direct measurement. In this case, we actually can get the information that we're looking for, the name and address of the pizza places of Windsor. It's not going to be super easy, but let's get started with that. I will share my screen. So what we are looking at right now is the Windsor-Essex County Health Unit's webpage showing their food safety inspections. Okay, it's presented as a table on the webpage, a table with pagination. You can see there are 112 pages of inspections, but it's also more than just restaurants. There are a number of different types of facility that are listed here. Unfortunately, there's no way to download this data directly from the health unit, which is a little unfortunate, but we can work around that. So what we're going to do is we're going to use a technique called screen scraping. This is a technique that can be automated or it can be done manually. You can write code fairly simply to perform this task. One of the things that I did in preparation for this event was just to understand the tools that are available to people. I asked ChatGPT if it could scrape this website for me. It couldn't for a number of reasons. One reason being that this website has a form that you have to agree and accept before you can get to the web page, which represents apparently a barrier. But also some versions of that tool will not access external websites. The data doesn't get returned to you in a format that you might prefer. So I tried that. I think that if you wanted to go that route, you would be better off to use the tool to guide you through the writing of a script. But in fact, our data is not that extensive. We can manually scrape it from the web page. If it was 112 pages, that would be a little bit tedious, but we are going to narrow that down by making sure that we only get a list of facilities that have pizza in the name. So we then get the disclaimer, we accept that disclaimer, and now we have a list of all facilities that have pizza in the name. And you can see we're looking pretty much at pizza places. It's a 5-page list. So how do we scrape this data? What we do is we take our mouse cursor and we position it at the top left of the data that we want to grab. And then we hold down our mouse button, hit Control-C. If I can find a way to open my taskbar. I'm stymied by the Zoom control panels. Just bear with me a minute, folks.
Hit the Windows button. So.
Thank you. That worked. Okay, we want Excel. Okay, so I'm going to open a blank workbook and Control V my data. Okay, here we have a little bit of mess that came in at the top of our scrape. Hit delete. And now what we have is, besides this weird guy here that I want to get out of here if I can. Okay, well, this is just a demonstration, so we'll leave it. What you see here is each cell has a different element. Basically, that table that we saw on the WeChew website is replicated exactly in a spreadsheet. And what we're most interested in is that each cell of that spreadsheet represents a cell in the data set. So we're in good shape. We can then scroll to the bottom, to tap into the cell, and to continue this process, and there I use my Windows key trick again. To continue this process, we would, go back to the WeChew website, hit the next page, scrape the next bit of data, paste, clean up, and so on. You get the idea. So what does that look like as a finished product? I've done a couple things here. I have pasted all the data, reshaped the cells so that I can see everything that I want to see. I've also removed all of that formatting. The way that I did that in this case is by saving the document as a CSV file. You can see this is pizza.csv. So now we have a list of pizza places and addresses. Now, one thing that's really important to keep in mind is that the list of pizza places that you get by searching the word pizza is not comprehensive. There are some other pizza places that don't use the word pizza in their name. The big two that I was able to identify are Oven 360 and Little Caesars. We're doing a demonstration tonight and making a map for fun. So my method for figuring out what restaurants were missing was sitting down and thinking about it for 5 minutes. There may well be other pizza places in the city that we didn't capture. If we are seriously looking to do some work and we need our data to be entirely accurate, then we would want to think about some way to cross-validate the selection that we had made in order to make sure that we're as comprehensive as possible. And that's a place where, for example, using a secondary method, some data that maybe not be acceptable for our base purposes, like a Google search or a Google map search, might be good to just to cross-reference against our own list and understand where the missing stuff was. So I'll leave that piece as an exercise to you, the person who's watching me, but that's the approach that you could take to ensure that your data was as comprehensive as possible. So now that we've got names and addresses, we still need some more information to be able to get this data onto a map, because mapping software doesn't understand addresses. We can't ask our software to map 150-24 Seacliff Drive. That's not going to work. What we need is latitude and longitude for each of these locations so that we can place it on the map as a point. And there are many tools to do this. The technique is called the geocoding. There are a lot of paid and free tools that you can use for this. Google provides some tooling, but what I landed on is a tool that's really suitable for this specific type of task, which is if you have a small data set that you would like to geocode, and there is no concerns with privacy, I would not use a tool on the web like this if I were, for example, a clinician and I was trying to geolocate my patients' homes. You might have to do something different in that case, but we're not really worried about violating the privacy of Pizza Plus, so we can use a tool like this. And what you do is you take your CSV file and you upload it. So I'll do that now. So what we're looking at now is the GeoAppify web page. and here's a preview of the data that we uploaded. Okay, then this tool is asking us which column should be used for address search. Well, it's definitely this one. And what's interesting here, you can select which field has which address component. And when you see the output of this tool, you'll see why it may be more valuable to separate out the data elements and in your spreadsheet before you upload. But we're just going to do it like this. You're going to geocode. Sounds great. In English, please. Okay, and it takes a little while. And we are not going to wait for that. We are instead going to switch over to a file that I previously geocoded. And what you're looking at here is actually the sort of sanitized output. Some stuff that's missing, I will maybe look at that file when it's finished downloading. Some stuff that's missing, geocoder indicates the data source. So it actually looks in multiple data sources, including OpenStreetMap and other sources. And it gives you a confidence interval for the geolocation. And that's really useful because what I found when we did this work is that there were a number of pizza places whose address wasn't properly recognized, and I had to come through and do a little bit of cleanup. And how I did that was I looked for entries that had a missing element in this sort of list here. So we have the address over here. Geocoder reformats it, expands out things like Ave or road from the acronym into the full name, puts in commas, basically tries to construct the formatted address. And it also separates out each address component. So when you scroll through your geocoded data, you'll see missing elements in the data. Now, one thing that we're not seeing missing here is street addresses. And the reason that there are none missing is that I went back and I cleaned up this data. I found the locations that were not fully encoded. I corrected the address. I went back and used a manual geocoding tool in which you can enter the address into the web browser and cleaned it up. I had to do that. It took about 20, 25 minutes just to kind of get this data into better shape. And then we end up with something, though, that has the latitude and longitude of the, it's really funny because this one's not showing it. So maybe this is not the correct file, but let's try that again. Recent files. Why does Excel default to tab delimited?
Because Excel is the devil.
It's weird.
Mm-hmm.
Okay, so this is the correct version. You can see that it includes the latitude and longitude of the location as well as all this other data. And there we are. There we have the confidence in the geolocation, which is really helpful. The data source, how you have to attribute it. Lots of good information here. This is a GeoAppify is a pretty good tool. Recommend it.
Cool. What's the lowest confidence that it shows you with that?
The lowest that I saw was 0.5.
Oh.
And it was wrong.
Oh.
So that was a few locations in the county. It got confused by the way the address was styled. And so it threw the address away and gave us the community, like the centroid of the community as the geolocation, which is a fail, but not a horrible fail, depending on what you're trying to do. Yeah, pretty neat tool. So once you have the list of pizza places with latitude and longitude, you can go ahead and place that on a map. So we have a finished map that I'll show you later, but let's just start with an empty one so that you can see the process. In QGIS is the tool that we're using now. We've actually done a number of border city data events that use QGIS, and there is a video on YouTube of a QGIS tutorial that was hosted here. So we're going to zoom through some of the QGIS elements of this work, but I want you to be aware that there is more detail available to you if you want it. QGIS is the open source geographic information system that is pretty much a clone of ArcGIS and is meant to provide a lot of that same functionality at no cost. So if you're a hobbyist mapper, this is pretty much essential tooling. QGIS considers maps in terms of layers. There are a couple of different kinds of layer that we can add. Okay, in this case, what we are adding is a delimited text layer. Okay, so when we do that, we get the nice little data source manager interface up, and we are looking for CSV file. So that will be there. I think this is the one, yep, that we were using. Okay, so when you load a CSV, then you need to identify what field. Oh, I got the wrong one, of course. There we go. What field contains your point coordinates? So longitude and latitude are in the lon and lat field. We need to know the coordinate reference system that is being used. What you need to know about that, if you're going to be using latitude and longitude to make maps, is that WGS 84 is the correct coordinate reference system for you to use. Okay, and we've got a little bit of sample data in here. We can scroll down and see the actual data. Looks pretty good. I click add, and we've got pizza places on the screen. Unfortunately, we don't have a base map yet, so this is not very attractive or informative. Although you can sort of roughly see the shape of Essex County and even some of the major roads and highways. And you can see where Windsor is. So we've already got a map. It's just not a very detailed map. Let's just zoom in a bit. So putting base maps on a QGIS map, there's a number of different ways we can do this. OpenStreetMap, I've mentioned before, is a pretty good source for a base map, and I'll show you what that looks like. We can use the plugin QuickOSM to query OpenStreetMap, and we can query on a highway, which is a street. Okay, in Windsor, Ontario, you can see that this is something that a search I run fairly often. We can run that query, and QuickOSM will go out to the OSM query tool, the Overpass API, and it's going to come back to us with a couple of different layers. It gives us a separate layer for each geometry type. So you can see that we've got lines, points, and polygons here in our layer index. So we can close this query tool up. And because we only looked for Windsor, here, let's do some things. Let's turn off that, turn off the polys, and we'll zoom in so that we're just looking at Windsor. And okay, so what you can see now is you see those pizza places. Let's change the order so that the pizza places are on top. While we're at it, we'll rename this layer so it's a little easier to know what we're dealing with. And now what we've got is a street map of the city without a geography base, but a street map of the city that shows us the pizza places.
Question. Say you wanted to do this for other cities. I just noticed that you searched for highway and not street. Is there a reason for that?
Yes. So let's just open up the OSM tool again and look in the keys. So there are specific keys in OSM And you do have to know a little bit about them. So highway is the key that provides that street mapping. There's a lot in golf, all kinds of stuff in here. So what we're looking for here is highway. There it is. Okay. And then when we click highway, we can see under value, we can see the kinds of highway. So we've got footways, streets that people live on, motorways, all different types of highway, all different types of road are available. And you can actually, you can query more tightly if you only want, for example, if you only wanted cycling paths, you could query just for cycleways and get that kind of a map. But you can also query for different communities. So you could do an OSM query that covered Amherstburg or Toronto or any place on the globe, and you can ask in your query for any kind of information that OSM stores and bring that in as separate layers. It's pretty useful. We're not going to use it tonight. I just wanted to show it to you. So we're actually going to delete all these layers now.
So if anybody does want more info on OSM, though, we do run events specifically on that coming up on the 21st of February. We're doing a map night, which is a nice intro to OSM if you haven't used it before and want to learn a little bit more about how it works.
That is correct. We like OSM here. We use it a lot. Okay, so we'll remove all those layers. And the reason that we're not going to use this tool, that particular tool tonight, is because we need our geography to be broken up into discrete chunks, discrete polygons that we can use to measure the pizza places against. And so for that, there are a number of different tools that you could use for this. The tool that I always reach for when I need to subdivide a community in that way is the census subdivisions that are used by Statistics Canada. This is looking at the GUID, which is not exactly what we want. So let's see.
GUID. I like that.
Okay, here we go. So I'm picking up dissemination areas, and that is one choice that you could make. The dissemination areas are, well, Fraser, you're pretty knowledgeable about Statistics Canada stuff. Is that the standard sort of unit of measurement?
It's substandard. So census tract is usually standard, which is 5,000 people. A dissemination area is about 10 areas per tract. So between 500 and 700 people per sort of square or polygon that you see on the screen.
Okay.
Census tracts almost never change between censuses. Dissemination areas will change between censuses. So then you have to get in, you're comparing 2016 to 2021. I think in Windsor, 30 dissemination areas changed. So it went from 330 to 360 areas. So they created 30, but a lot of that was because they took an area and chopped it in half or something like that because of population growth.
Thanks. That's great. That's really helpful. So DAs are nicely small. So they're something that is good if you want that level of granularity. What I actually used for this map was dissemination blocks, which are even smaller than dissemination areas, because what I'm aiming for here is a very, very fine-grained pool. And without looking for something that's more comprehensive, something that's outside my wheelhouse, there may be, for example, more regularly gridded subdivisions of Canada available that might be useful. If you were really going to do some kind of sort of scientific operation with this data, you might want to make sure that each geometry was exactly the same size, for instance. We're not doing that. If for our purposes, it's good enough that each geometry is in the ballpark of a similar size to each other. And even there, you'll see some artifacts when we get outside the city of Windsor in the map that some of those dissemination areas outside the city of Windsor, it takes a big area of Essex County to fit 700 people sometimes. So some of those can get pretty big. But the dissemination block worked out pretty well for me. So that's what I chose to use. So we're looking at DA boundary files. Dissemination block boundary files are not so different. You can see, as Fraser mentioned, that census years, they do move those boundaries around. So you can grab the file for your specific year that you're interested in. In this case, there's no reason to use anything other than the most recent one. And there is actually change your choice here. So what I did is went down to dissemination blocks, grabbed a shapefile, and downloaded that file. So once you have that file downloaded, you can go back to your QGIS and you can add it as a layer. Now, in this case, a shapefile, which is the file format that Statistics Canada provides that data in, among others. Shapefiles are one standard. GeoJSON would be another, but shapefiles are one standard for data interchange around GIS type information. They're pretty useful. They are based on, they're actually the file format used by the ArcGIS product I mentioned before, and they're also quite widely used. Like you'll very often find map data provided to you in shapefile format. Shapefile is kind of interesting. It contains, it's a zip containing a few different files, one of which, for those of you who are interested in computing and software history, is a DBase for database. So that's kind of cool. If you ever need to dig deep in a shapefile, you may find yourself searching the web for old DBase tooling. I've had to do that in the past. Okay, we're going to add a vector layer. We're going to grab that file that we downloaded. So this is what a shapefile folder looks like with the shapefile index, a little XML file, which I am actually not sure what data that contains. I'm sure it's quite essential. The data file, and then I believe this is the information about the map projection. So that would be the sort of the set of files that make up this shapefile. I can click on the .shp. Okay, all the defaults look good. Add it. Okay, and QGIS wants me to know that I have combined two files with different coordinate reference systems. And it wants to know which transformation we should use. And it identifies some information about that, like the accuracy of that format. I'm just going to take the default here. 4 meters is not going to make a difference into which pizza place has the biggest area. Okay, so now we have our base map. If we reorder our layers over here on the left side, the colors that were chosen are not very perfect, but you can see, oops. But you can see that you can see all the pizza places now overlaid onto the map of the county and to the map of the city. You may have also noticed that our map extent is much bigger now because that dissemination block file covers the whole country. So our base map is now all of Canada, even though we're only interested in one small corner down here. Let's go back. Okay. Okay, so we have pizza places as pins on a map. That's where we are so far, okay? Well, in the time that we've taken to do this, you could probably have taken that list of pizza places and used push pins on a paper map to accomplish something like this. So it's a good thing that we're not finished because this is not very impressive. What we now want to do is we want to join these two layers so that these two layers are aware of each other. So I'm going to actually just cheat a little bit and open up my finished one so that I don't mess you guys up. Oh man.
I have a question. So like these lines, they don't represent streets, right? No. They represent like blocks of population.
Yeah.
Based on population. I'm not following the logic as to why is it that you wanted to grab this. I mean, other than it looks pretty.
So it does a couple of things for us. One, it looks pretty. It gives us some reference for our map. But you're right, it doesn't look very different from the street map we had before. And in fact, that street map was more accurate. You can see the outline of the major streets in Windsor and some of the residential streets from this map, but it's not comprehensive. The difference is that every single box that you see on that map is polygon. So we can apply processing to those polygons in a way that we can't do with just a flat map of streets. That those lines of streets don't allow us to do any kind of processing in terms of like the geometry of the map. But because we have this as polygons, we can do that. So as I said, you might want to find a map that has more regular polygons if you're interested in something that has a little bit more consistency of geography. In this case, and I do this a lot for Maps for Fun, we're combining the tool that we're going to use for analysis with the tool we're going to use for presentation, because in this case, it's good enough for both purposes. But if you were going to do this in a more rigorous way, you might use some other tool to subdivide your geography more evenly, and then use a separate tool to visualize the street network or other surface features that you want. So what you'd end up with is just more layers on your map. All the same principles, all the same sort of things that we've done so far, just a little bit more time and a little bit more care.
Follow-up question. So, for example, if you were able to get this as a street map in such a way that the lines of the streets actually created polygon shapes that you could apply.
Yeah.
Would you use that over this?
I might. Okay. I mean, one thing that's nice about this is it's a very known quantity. So using the statistical base maps, like the Statistics Canada base maps, there's a reason why this is a tool I reach for, because it's very often the appropriate tool, especially when you are surfacing data about the population that comes from the census. And that's very often something that I'm doing, or I'm combining census data with something else. So in those cases, using a census base map is essential, because the data is all based on those specific physical subdivisions. And then, being perfectly honest, it's a tool I reach for because it's a tool that I use a lot, because there are some applications where it's the essential tool, if that makes sense.
So with this one too, you'd also be able to see like how many people a pizza place serves.
That actually is a great point, because there are some things that you could do as further work, like things that you could do that we're not going to do tonight. And that's one of the things I wanted to talk about was because we're using census maps, that would allow us to do things like calculate the population within each pizza place's sort of theoretical zone of influence. So that's not something that we could do unless we had, unless our data and our map have the same subdivisions and are the same. So for that purpose, we would need to use a tool like this. And again, if we were using a street map, we would then, in order to do that population analysis, we'd end up putting a census map here anyway. So those are the kind of the considerations I'm really glad that you probed for that, though, because these are like, I reach for these maps now because it's the tool I reach for when I need a base map. And it's really good to like sort of talk through, well, how did we get here, right? Okay. All right. So how do we figure out how these pizza places relate to the geometry on the map? Well, we're going to do a join. I wanted to look at my other map to make sure I didn't do this in a crazy way. Okay, so this looks pretty similar. And then we have the joined layer. Okay, and the joined layer. Actually, right. Oh, isn't that interesting? Oh, yes. Okay. What happens is this layer disappears when we, okay, so that's not going to be much help to us. So we're just going to go back here. Okay, so in some cases, we would need to join these two. Layers by using the tooling provided in the layer properties screen. So this is one way you can do this. You can create a join here. One problem with that is that it relies on the data, the layers that you're using to have an inherent connection to each other. That if there is a join possible, just like a SQL join, we have a field in both layers that matches up. Okay, that's not possible here. That's not possible here because our pizza places don't know what dissemination block of the census they're in, and the dissemination blocks don't know anything about pizza places. So we can't do it that way. But while we're here, we are going to just change the symbol for the pizza place. Okay, so there are a few options here. We can use a simple marker, but there are other marker types available, and one that I want to show you just because in this case, we can actually put a piece of pizza on the map. Okay. All right. And then we can pick our color for our little pizza pie. Doesn't really matter. We're going to go blue pizza. Actually, we better go gray pizza because our coloring is going to be all over the place. All right. So we do that. And now those little pizza places are kind of hard to see. Okay, that's going to change, but maybe we want to use a pure black or a pure white. Let's go with pure black. Okay. All right. Now, one thing I'm noticing is that those pizza places are really hard to discern against the solid black of the definition of the polygons. So we can go into the styling of that layer as well. We click on the simple fill. Actually, we should not do that now, I realize, because this is all going to get wiped away. So I'll show you how we're going to do that. In the processing toolbox, there are so many things that you can do with your map. And I'll be honest, I've barely scratched the surface of what the processing toolbox can do. But there are a ton of things that you can do if you know what you're doing. And even if you only sort of know what you're doing, like me, you can go in here and figure out what you need. So what we want is this processing tool, join attributes by nearest. Okay, so this is going to join a layer to another layer by using the nearest feature. So how does that work? Let's try it. Okay, so we are going to process the pizza places. I believe this is the sequence we want to do. Okay, and we're going to run into some errors here. And because we are, oh, I cannot do that.
For this join, does it matter which one's first, which one's second?
It does. It does. And I'm not 100% sure that I've got it right, but we're going to try it. Okay, so this, we're going to hit run, and it's going to say, wow, this geometry is fine. So there's a bunch of invalid geometry, which is not relevant to us because it's not inside the area of the country that we care about. So these errors, I don't really understand what these errors are pointing to, but it does not impact our work in Essex County. And based on work I've done in with maps across the country, I can tell you there are places in Newfoundland where QGIS has a really hard time because the polygons are well, they're shorelines, so they're so fractal and they're so detailed that it can become an issue. Doesn't matter for our purposes, so we are lucky. Essex County is flat, and apparently our little dissemination blocks are pretty evenly and easy to understand, evenly spaced and easy to understand. So here we go. Our joined layer now So we can turn this layer off, and we now have a joined layer that we can take a look at. Okay. Nope, we did it in the backwards order. So what we did is we joined the geometry in the we joined the geometry to the points instead of joining the points to the geometry. I had a feeling I was going backwards, but now we have proved it. So we'll remove that layer, and we're going to do this again. Nearest neighbor analysis. Okay, here we go. So the input layer is actually, there we go, the dissemination blocks, and input layer 2 is the pizza places. Okay. Only one nearest neighbor. Let's run that again. Wow, that goes a lot faster now. One thing you have to be careful when you're working with QGIS, as we just saw, I had a joined layer that was not saved to disk. It's just a temporary layer in memory. So when we had to reload our map because my computer blue screened, we lost that lovely map and we have to start again. So just something to think about when you're working with scratch layers. If your hardware is unreliable, you might want to save early and save often. All right, that looks a little better. We ended up with polygon joined layer. So now we'll remember that for next time. I'll definitely remember it since I made the mistake in front of all of you. When we're joining attributes that we want, whatever we want the layer to display as is what we want to use first. So we want to display it as polys. Okay, so now that we've got this joined layer, this doesn't look like very much of a progression over our previous work because it's just kind of a different color map. But what we can do now is we can jump into our properties, and on this symbology page, instead of a single symbol, we can choose. There's a number of different ways that you can put symbols on your map or color your map, whatever. And we're going to choose categorized, okay, which allows us to take a field out of our data set. And I went ahead and pre-created in our spreadsheet a label. And the reason I did that, I'm just going to jump back to the spreadsheet to show you why. What I wanted to do was simplify simplify this list, and first make sure that we were providing a display name, but also we didn't want a separate map color for every one of the 100+ pizza places in Windsor. That would make for a pretty riotous map. It's already pretty hard to make sense of because of the complexity of the map. So I created a label column, and in the label column, I filled in an indicator for chains, and then all of the individual pizza places are listed as other. Okay. And so that is the reason why instead of the name, we are going to use the label. I think instead of the original name, we're going to use the original label. And then what we can do is classify our data. And QGIS goes and finds all the unique values before anybody tells me I typoed Domino's. Okay. And we can choose a color ramp. So what that's going to do, in this case, it's random colors, but you can choose, makes more sense if you are using data that is, instead of being discrete values that we classify, if your data is more continuous, then it makes sense to use one of the color ramps that is going to be more spectral in nature, so that it shows you an appropriate change in color from one set of values to the next. That's why you would use something like reds or red, yellow, green or whatnot. But for data like this, where it is random, there is no there is no rhyme or reason why any particular color should be a color. We're just categorizing, like just identifying the separate areas. We can use a random ramp. Okay, so when we apply that, and you can also shuffle the colors if you don't like the way your map looks, which is nice.
Okay, I like that less. We're going to try one more time. Whatever we get this time is what we get. Okay. All right. And click OK. Okay. And I still don't like the way those pizza places are looking. So I'm going to go back and into the properties of the joined layer. And we're going to dig a little deeper into our
You want to do it on the actual pizza places, so not to join that.
Thank you. Yeah, you're right. Right. That's why I couldn't see it. That makes a lot of sense. Okay, so I don't like that marker. Oh no, actually, Fraser, sorry about that. I was wanting to change something about. I wanted to change something about the symbology actually. So we're going to. There we go. We have to go down into our symbology. Okay, and do that again. So into simple fill, and here's where we can influence the lines in between. So what I'm going to do is I'm going to change it to a hairline dotted line. Okay, and when we apply that, that is just going to de-emphasize there. That de-emphasizes those street lines. You can still see the structure, but now we can see the pizza places on the map a lot more clearly. I'm going to expand our legend so that we can take a look. And also what you can do is you can turn off and on. This makes more sense to you. You can turn off and on one single color in your layer to sort of get a sense of like, okay, I can't tell if that's light blue or blue. So Armando's, and we're seeing there's Armando's sphere of pizza influence in Windsor. Here's Boston Pizza. Boston Pizza's there. So basically what we have done in the processing is that we've taken each pizza place and we've identified for each polygon on the map which pizza place is the closest. Okay. And then colored that accordingly. So yeah.
What if, okay, so you're looking at which pizza place is closest to the shape? But there's multiple pizza places in the same shape.
Okay, so it gets kind of interesting. I was actually in a group chat with Fraser and talking about this, and this was the example I was looking at. So we've got two pizza places here, and this geocoding is interesting because these two pizza places are actually in the same plaza. So here's two pizza places, and the center of this polygon is closer to this pizza place down here than it is to this one. So we end up with some weird effects where this entire neighborhood is all, who is that? That original guy?
It's using
Pizza Depot?
It's using the center of the shape?
Yes, that's correct.
Question, do you know what it's using as quote unquote the center of the shape? Because is it like the center of mass of the shape?
How the centroid's determined, I couldn't tell you off the top of my head, but yeah, it is using the sort of like the center of the shape. So you get these odd effects where you'll have like one polygon that the center of this polygon, this one up here, is way over here. So it's closer to this one, and it's kind of nifty. So there are some odd effects that you get, but for the most part, it works pretty well.
What is that blank spot?
Right here, is it something I've got turned off?
Oh, because there's a couple of them.
Okay. Oh, those two blank spots there. So I actually think those may be polygons with failed processing. Yeah. So we might have a couple of polys that didn't process that are in Essex County. Okay. I didn't notice that on my previous map, so I'm not 100% sure what happened. It could just be the demonstration effect because I'm showing all you fine people, and my data decided to be weird. But yeah, I think that's what's going on, that those were polys that didn't process.
On this one?
This one down here? Sure. That's, yeah.
Curious.
Little Caesars. So there's a Little Caesars here.
Yeah.
But then this is all Chachi's territory, I think.
And then there's this one up here. And so it's getting like, it's weird that this red one here is, well, red, but then the one next to it is purple.
Yeah. So I kind of mentioned a little earlier that I think you got to be thinking about whether it might make more sense to use something that's more regular.
Yeah.
So to minimize this type of effect, right? If something that like, because you have two polygons next to each other that have radically different shapes and radically different sizes, that's going to lead to this type of effect, right? We're not making the definitive government pizza map. We're making a fun map for us. So those are some things that you might want to consider if you're inspired by this discussion and you want to make your own extra special super pizza map. You might consider some of those details and think about how you would go at it. But essentially, this is what we've got. And now I want to show you just a couple more things. And now I have to refer to my notes.
For you.
Yep, go ahead. Please.
I'm a little bit confused. The colors represents these as places.
Right. So what we did here in this join layer, we decided to categorize the symbols, which in this case is the color. And so we pick a field in our data set. Let me show you the data set.
Yeah, what I mean. Yeah.
Okay.
What I mean that this is, for example, the pinky one is very big. It means that it has more than one piece of place, or what is?
What it means is that there is not another pizza place close enough. Right. So the one thing that you want to think about when you're looking at this particular map of Windsor is that there's a big swath here where the nearest pizza place is other. Most of the city, the nearest pizza place is other, because Windsor has an incredible variety of pizza places, of one-off pizza places all over town. In that case, like, this map is really poor at showing Windsor's pizza diversity, because the pizza diversity is all in that blue area, right? So we would probably want to choose. So what would it look like? What does it look like if instead of using that label, we decide to use just the name of the pizza place to color the map? There we go. Okay. And that's what the map of Windsor would look like if we color every pizza place individually. Here's our big list. Now, one problem that you start to get into is that there's not like over 100 distinct colors available. So you end up with a little bit of a mishmash here. But you can see more clearly, I think, from this map, the way that, like, the amount of diversity that there is in Windsor pizza. The other thing that I think is interesting is that you can see some patterns. Like, it looks like locating your pizza place on or near Tecumseh Road is a strategy that's used quite a bit. There is a horizontal line that's running through approximately the middle of Windsor. That's Tecumseh Road. And you can see that there is a huge cluster of pizza places there. There's also, maybe not surprisingly, a huge cluster of pizza places concentrated in the West End, where you have a lot of students. That's where the university is, so that's kind of interesting. And then some other neighborhoods that we would expect to be pizza place heavy, like South Windsor, have a good representation of pizza places. But there's a couple other things that we can do. We can generate some statistics here. So we can do a nearest neighbor analysis. If I can find that in here. Why am I not finding it? There we go. Nope, that's nearest. There we go, nearest neighbor analysis. So what this will allow us to do, here we go, pizza places, Flip layer. I tried that. There we go. Okay, here's our results. There's an HTML file. So the nearest neighbor analysis is going to indicate to us how dispersed or clustered our points are. And I did a little bit of lookup on this, and the nearest neighbor index, lower numbers would indicate more uniformity, and higher numbers, lower numbers indicate more clustering, and higher numbers indicate more dispersion, and that you expect to see a very higher number in a competitive environment where people are competing, pizza places are competing. So the ideal for a pizza place is to be, evenly, all pizza places in the city to be evenly geographically distributed, or at least evenly by population. And I think that's really interesting that you see that. Yeah.
Is that analysis skewed by the rest of Canada being on the map?
No, because we're only using the pizza points. Yeah. So we're only using the pizza layer. I consider that as well, but yeah, so that's only an analysis of these. You can see, and I think that we talked a little bit earlier, that it would be really neat to apply some population weighting to this data as well, so that you could understand what the total number of people within each pizza place's nominal sphere of influence is. That's something that would take a little bit more work, and if it might be interesting, and in fact might be commercially valuable. If you own a pizza place, or you want to own a pizza place, this is an analysis that might have some value to you, to understand what is the best place left in the city to put a pizza place, right? What is the geography that would give you the biggest slice of the pie in the pizza world if you placed it there? And that's an analysis that you could probably use these tools to perform and come up with a pretty good answer.
So we have a question in the chat.
Yep.
Can you do nearest to a polygon's edge instead of its center?
Possibly, but I don't know how. So that would be something I'd have to research, and then you'd have to ask what part of the edge. So the nice thing about using the center for this analysis is that there's only one center, and I'm not sure how you would do an analysis on any one point in the perimeter of a polygon, and like how you would pick which point on the perimeter, especially when you get into some of these very irregular shapes. So I don't know if that's something that folks do, but if it is, I don't know how to do it.
Can you zoom in on this spot right here where that's got to be like Tecumseh at Howard, where they're like stacked on top of each other?
It must be. That's a great segment of the pizza map where we have 5 pizza places. So let's find out what they are. We can do that pretty quick. Click on properties, and we're going to add a label to our map. We're just going to do a single label, and this is not going to look nice in any way, shape, or form, but it'll look okay here. So there you go. It's kind of that is quite an interesting competitive environment. And if that is Howard and Tecumseh, I guess the Napoli pizza person has to balance the attractiveness of being at that location, at that key location in the city, versus being, having the smallest possible territory for a pizza place. It's one block.
We've seen McDougal and Howard there.
Yeah.
Yeah.
That's really funny.
Yeah, kind of cool. I'm glad you asked that question. And labeling those points, it looks okay at this zoom level, but it's pretty common. Like when you zoom to the level of the city, it just becomes mess, unfortunately. So it might be that if we were going to create a map like this, we might want to actually do pizza neighborhoods of Windsor. Because when you zoom into the neighborhood level, you can fit some nice looking labels on it, and you can you can still see quite a bit of detail. The other way you could go here, which is completely out of scope for this conversation, but maybe we could look at it another time. The other way you could go here is use a mapping tool for the web browser and generate a web map, which would allow for things like having labels appear at an appropriate zoom level and disappear when that zoom level becomes too intense, having different features turned off and on and so forth at different zoom levels. That's something that we could do with a web map, not so much with QGIS. I know we're a little over time. There's just one more thing I want to show you folks. So I'm going to go and zoom into my own neighborhood, and I am going to generate a print map of my pizza neighborhood. Okay. Oh, no, I did not want the full extent of Canada over here.
I'll just check. Are we over time? I thought this was until 8 p.m.
Oh, you booked it till 8? Okay, it's a 2-hour event apparently.
Gives time.
Okay.
That's this.
Yeah, you're right. Okay, we're having some fun. Okay, so here we're going to take that little nasty part off. What's that?
I ordered pizza.
Did you order a pizza?
That's
Wow.
So Fraser's got a pizza coming. Now what are we going to do?
Well,
Okay.
that's what happens when you get your instructions from Doug. Check the website. Yeah. Sorry, Doug.
That was a pretty hard undermine there, Lauren. Okay, we're going to create a new print layout for our map, and this is how we take this map on our screen and we turn it into something that we can print and display. Okay, so we're going to call this Doug's Pizza Universe because that's what it is. Okay, and now we get a little print preview. So we have different components of the map over here. I'm going to drag a map component, fill the page with the map. Okay, and then I am going to bring the legend over and put a legend on the map. Okay, wow, that's a big legend. And I guess actually, if we were going to do this properly, what I'd want to do is figure out which of these pizza places actually need to be here, and then do the coloring that way, or just lose the thing altogether because you actually have the labels on the map, so the colors are kind of self-explanatory. So in my neighborhood, this is the state of pizza conflict. My nearest pizza place, according to this map, is Pizza Depot. My next nearest would be Little Caesars, but I can tell you that Antonino's Original Pizza is where I go to get my pie. Further afield options would include Armando's, which seems to not appear on this map because of choices made in data acquisition. So I think we're going to stop there with an imperfect map created through an imperfect process, but hopefully through this process where we sort of rushed through acquiring data, geocoding that data, dropping that data on the map and performing analyses, all squeezed into a little over an hour. If you wanted to take a little bit more time with a project like this, you could end up with something a little bit more comprehensive, but we've seen the process, and I hope that I've sparked your curiosity and interest in exploring one of the many areas that we touched on today. And I do encourage you to look through the Border City Data Catalog on the Hackforge YouTube channel, because we have covered a lot of these topics more than once, and there's a lot of detail out there. So if you're interested in a deeper dive in one of the multiple things that we talked about tonight, there's probably a talk that goes deep on that one subject. So with that, I'm going to see if there are any final questions, and then we're going to let Fraser get to his pizza.
Can I ask Fraser a question?
Yes.
So there's a lot of spots in here. So if you're looking at Doug's map, for example, I don't know how well you can see it off the projector, but where it says Little Caesars, just above that and to the left, there's a really small, skinny polygon.
Apartment
building. Oh, that makes sense.
So this is a block level. That's a block level map, right? Mm-hmm. So it's smaller than the DA. So that could be a single building. So it might be I don't know what, but it could be,
Okay, interesting.
It's the first time I've worked with census blocks. It was just something I thought I would try. I'm not sure I would use it again for this kind of purpose because DAs
would give you a cleaner, like those random bubbles there would disappear because that would all be one cluster.
Right.
So if you take 10 of those squares, generally, that adds up to a DA.
Right.
So if you were to take groups of 10, suddenly like geographic congruitous groups of 10, you would end up with like.
It would definitely smooth out that color weirdness effect. The flip side is that you'd get some wonky centroids. So like you could end up with.
Generally, they're more square, right? The DAs, until you get into large rural areas, like in the city, they're, down a wet to 3 blocks wide, 10 blocks deep or something like that, right? So they tend to be pretty square unless the geography starts getting constrained, right?
Okay. So maybe DA is a more appropriate choice. In fact, I built a map like this a few years ago, and I think I did use DAs back then. But I wanted to try blocks, and I think I've learned something about when to use them and when not to use them. And maybe this is a case when not to use them, but you often don't know until you do the experiment. So one thing I would suggest, if you're going to try to repeat this for yourself, try using dissemination areas and see what kind of output you get. Okay, so no other questions in there?
Question.
Yeah.
In terms of the census data, so you can get data like this where the population is broken up into even parts in these geometric forms.
Yep.
Is there more akin to like heat map of population-esque data?
You could take that population data, link it to this map, and then use those gradient the gradient colors that he showed.
Yeah.
You could use that to generate a heat map, right? So yeah, you could build it. It doesn't come that way.
And each polygon would be one shade. So you'd be at the right. So you can't see population distribution at any more detail than whatever the polygon size is.
Yeah. My only thought was that like the issue with the polygons, which you mentioned before, is that like they are not uniform shapes, right? So I could estimate population. I could estimate a population heat map, but it wouldn't be quite exact because some of these weird, like thin, long shapes type thing.
Right.
Yeah.
So another way that people do this, I was thinking, because I was talking earlier, I was saying earlier that I don't know of a way, or I don't know of a map layer that provides a uniform sort of geometric approach, but there is a technique where you basically subdivide the whole country or the whole area that you're interested in into hexagons. So you end up with a hex map, like a Dungeons and Dragons map. You end up with a hex map where each hexagon is the same size and shape, and then you just bin it. So you bin whatever data fits into that hexagon, the underlying data. You stick it in there, and then that's your unit. And that can be nice for a couple of reasons. Like it makes a nicer looking map of the geography. It's a more uniform appearance. And we've used it. We've used it before, and Fraser and I have a data podcast with a couple other people that we do together. We've used it before for doing things like looking at electoral results in Canada, where you, rather than like actually show the shape of each riding, you break each riding down into a square or a hexagon, and you kind of have a more abstract but still recognizable map of the country and more realistic output. So there's tools like that as well. Okay. All right.
We got somebody who said, this is my first event and I absolutely loved it. Thank you for hosting this. Look forward to being involved with y'all more.
Well, much appreciated.
Very nice.
Yeah. All right. Good stuff. Okay. Well, so this was a bit of an experiment for me. I'm normally a lot more prepared and scripted, but I had a lot of fun. And I think it was the group at the table, and you guys online were really quiet. I'm sure you're all awesome too, but the group at the table, I think really helped to make this a lot of fun tonight. So thanks, folks, and have a great night and happy mapping.